Okay. My name is James D. Cruz, and I'm going to demonstrate microprocessors experiment number 3, which is programming with time delay using 7-segment display. Okay. So we're going to use the 7-segment display of ECEA105L-E01. Yep. For the first part, time delay using 7-segment display. This program will display numbers 1 to 4 using the SSD. Okay, we have already launched the ECEA51DL simulator. Yep. And encode the following starting address 0000H. Okay. So we have to encode this one. So I have already prepared this code. It is the same as this code. So you can also copy this one. You can just copy paste it, then paste it here. Yep, and it's already here. So save, assemble, and let's run it to first frequency. After assembling this code, the code number 3, and running the code 2, 3, this is the output. Analyze the program with the output, click pause and reset, edit the program. Okay. And to observe the output, click run and answer Q1. So I have already answered it. Uh, okay. What is the output of the program? Illustrated using a picture or a drawing with an explanation. So this is the output of the program. So at intervals, one, so it changes the LED lights up per interval. So how come it is so fast? Wait. So the instruction here, it says 45H, but I made it 5H to make the output faster. So if it's 45H, the delay would be 45 seconds if I'm not mistaken. Alright. Displays 1 for 45 seconds. Next, it will display 2 for 45 seconds. Then 3, 45 seconds. Then 4, 45 seconds. So it takes a long time to display. That's why I changed it to 5H. But basically, that's the output. Also, the LED changes here. So what is happening here? In my interpretation, the set B here, P3.3 and P3.4, these two ports are being manipulated to change the LED display here. Yeah. So this is the SSD or 7-segment display shown in the NCM51 simulator. And here, this is the first, second, third, and fourth LED display. So by manipulating P3.3 and P3.4, we are able to change which LED shall be used to display the output of the binaries. Oh, yeah. Okay, so wait. Right. So this is the output of the decoder, and this is 7-segment display. So by manipulating this one, A1, A0, P3.4, P3.3, you will be able to choose which 7-segment display you want the LED to be like. For example, if you set this P3.4 to 0, then this one is 1. Let's say this you you will automatically choose this display. If you set this 3.4 to 1 and you set 3.3 to 0, you will automatically choose this one. It's just an example, but it's how it works. If you set both of these are 0, then you will choose this one like that. But yeah, it's something like that. And if you set this to 1 and 1, and yeah, you choose this one. That's how it works. And yeah, so you can see here, set B 3.3, set B 3.4, which means 1 1, right? It means it has a value. It means you set the P3, port 3 means the port for this decoder, yeah, and this segment display. If you yeah, it means you set it to 1 1, then the port, move this binary to P1, move this data to P1. Up. P1, as mentioned in previous experiments, it is port 1 for the LEDs, but it's not only limited to these LEDs. It is also used to light up the LEDs in the 7 segment display. Yeah, here. It also displays the resulting LEDs, resulting binary here in LEDs in 7 segment display. After that, it has a delay. Yep, delay 45 seconds, hold delay 45 seconds. After delay, go back and clear P3.3. The clear button clears the set P3.3, which means if it is set to 1, it becomes 0 again. So it clears the contents of P3.3. Okay, set B. Oh, that is how it works. So 1, 2, 3, 4. Alright, so heading on, moving on. Edit the program, remove B from the instruction addresses 004, 000B, 0014, and at 001B respectively. Okay, we have to remove it on the program. Let's just remove the B. See what happens. And I'll just turn it into 05 for a more faster output. So it has a less delay. Assemble then run. Okay. As you can see here, oh, error. Function set inversion. But here, if we are going to focus on the output, you can see that they are displaying incorrectly. The output is displaying incorrectly. So why is this? Repeat 4 to 6 to 6. Okay, run the program as Q2. Okay, repeat 4 to 6. 6 save assemble. Alright, yeah. Okay, answer Q2. Why is it displaying differently? Well, it says B stands for binary. Without it, the assemble would not be able to locate binary numbers and just consider the number as decimal. Thus, logic errors will occur, and the user will not be able to get the desired output where LEDs in the 7 segments would not be able to light up accordingly. So that is why it is important uh, to add the B in these parts. So the program will interpret uh, wait the program will interpret this into a decimal without the B. That's why you need to add the B, whether so that uh, the program will consider this as a binary. Okay, next. This time, edit the program by adding numbers 5 to 9 in the loop and to be able to display it through SSD. Repeat steps 4 to 6, then run the program and answer Q3, Q4, and Q5. Alright. Um, you have to load this one. So, okay, I have already prepared the code. So, what I did here is just, yeah, what happened here is for this step, yeah, we just added the codes to display 5 to 9 in the loop. Alright. And I set it to 5 hexadecimal for shorter delay. Let's see this one. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Yeah, you're just manipulating the display. Alright, then what are the added instructions in the program? These are the added instructions to the program, where this one is represents the binary for 6, 7, 5, 6, 7, 8, and 9. Also, we have our reference here. Yeah. Display. Yep. 7 segment display. So this one is the data that will determine that will be displayed in the LED. Yeah. Answer Q2. Okay. Then answer Q3, Q4, Q5. What is the output of the program? Illustrated using a picture or drawing with an explanation. Here is the output of the program, as shown before. This is the output of the program. It displays LEDs from number 1, 2, 3, 4, 5, 6, 7, 8, and 9. Why is multiplexing important in utilizing SSD? Cite an example and explain which part of the program performs the multiplexing. So multiplexing is important because it is capable to conserve port pins, wherein it allows inputs in each SSD to come the same port input. Without multiplexing, more pins would be required in each SSD. Multiplexing makes use of the instructions set D, clear, and move. These instructions manipulate the value stored in P1 and P3. Set B instruction is used to select the bits in multiplexing 1, which is the high. On the other hand, selecting bits in multiplexing 0, which is in low, clear instruction is used. Move instruction is used to set the input value, which will be multiplexed to multiple SSD. So yeah, so in short, the importance of utilizing SSD is to conserve port pins. Okay. Wherein it allows input in each SSD to come to the same port inputs, so it saves codes and time. It's more efficient. Part 2, input-output port interface with time delay using SSD. Alright, so this is the next one. Launch ISIP simulator, click the new and encode this address. Alright, so you can just copy paste this one, right? This one, and right click and copy, and then paste it here. Alright, pause. Yeah. You can paste it here, but simplicity, I have already showed it here. Yep. Yes. Okay, this is the code here. To save your program, save the speed of the output, click frequency, and choose one. To observe the output, click run and answer Q2 and Q1. Alright, let's see what happens here. So, alright, we need the press buttons. And let's just change it to 5 hexadecimal. This one, it displays this one. Alright, why is it happening like that? Because What is the output of the program? The output depends on the switches that are pressed, but to assume the program can light up a segment or LEDs in an SSD. The program fills in as the SSD illuminates, alternating the display 3 and display 2. Squeezing or pressing switches 0 and 1 lights up the fragment A and B of the SSD. The progressions of the estimation P2 depends on the switch squeeze, wherein P2 is put away in A, which is then put away in P1. Port pin P1 is inputted each SSD. At the point, the SSD will illuminate contingent upon the pieces 3 and of P3. The select pieces utilized for multiplexing are changed such that the chose 7-portion show will substitute DISP3 and DISP2. So what is the importance of executing instruction CLR and P3.3? It is very important because it plays the role of multiplexing through manipulating the selected bits. It is able to clear bit 3 of the P3 when changing the select bits. The selected SSD also changes the different DISP. Alright. Next, add another 2 sets of switch input and activate the third and fourth SSD. Alright. So these are the instructions that must be added between call delay and delay move R0/45H. Yes. We have to add the codes near line 15 and 17. Alright. We have to just load, and I have already prepared it. This is one. Alright. Then assemble and run. Okay, it doesn't work. But if we press the switches, yeah, reset. So we have to press it first. Assemble and run. Okay. Wait. 5-inch. Yeah. Alright. Uh-huh. Okay. So it just displays the 1, the 2, then 3, then 4. Yeah. But it doesn't repeat the cycle again. It goes back to 1. Alright. Because there's no jump. That's why it doesn't repeat the cycle. So it goes to 1, 2, 3, 4, then goes back to 1, and then ends the program. What's the output of the program? Illustrated using a picture or drawing with an explanation. So this is the output. Yep. The simulation becomes faster. Alright. Alright. So we have to set it to 100. Okay. What it says here, the simulation becomes faster because running the instructions in the program, the update frequency can be able to change in order to view the output of the program fast or slow. An output of the program can be faster if the update frequency is set to 100. But yeah. Yes. Mm-hmm. What is the effect of setting the update frequency to 100? Well, the output is shown on the 7-segment display. The first display digits upon depending on the pressed input switches. Changing the input will be shown on the second display. This happens after a 69 count delay from the PC. This goes on until all are done lighting up. There will be no repeating since there is no jump command after the call. Okay, So this is what happens. But let's make it 1. Okay. Yep. So this is the output. And that is all. Thank you for listening.